Welcome, and thanks for the opportunity to speak about our company, its products, and its services. AboveNV is a drone data company focused on data collection, analysis, and report for a wide variety of industries. We use unmanned aerial vehicles, often called UAVs or drones. We often hear that the drone industry is disruptive, and there's a lot of talk about drone delivery, cloud seeding, surveillance, and a bunch of other future tech possibilities. AboveNV is focused on what drones are doing right now. These are the services that blue-collar, unmanned aerial vehicles are providing. We provide services, equipment, and consulting with UAVs for various industries and agencies at a fraction of the cost compared to the current data collection procedures they're using. All land managers need to know what's on their land, now and for future planning and development. We provide the tools to do that, from the air, turning what's information on the ground into three-dimensional, highly precise maps. When we talk about maps, we're talking about point clouds, lots of information all on one big digital surface. But the current data collection in this realm requires either ground crews, manned aircraft, or satellite data. This can be problematic because those are either inaccurate, expensive, or inefficient. So with satellite, they can be free if you go to Google Maps, but sometimes we need a special orbit. That can be pretty expensive. The difficulty with satellites, obviously, is they're way up there, so their resolution isn't as great as it could be. At 12 inches a pixel, give or take, this makes it difficult to distinguish small parts of what's going on the ground. So the resolution isn't so great. With manned aircraft, you can get down to 6 inches per pixel, which is a lot better if you're mapping for city parks and that kind of thing. But the problem is that they're quite expensive. Remember, we've got an aircraft with fuel. You've got a pilot. They can only fly at certain altitudes down to the ground, and it can be expensive, right? So then we get down to ground crews. The ground crews are great, but they have to go out and make a couple of samples, and then you have to average from there. So really, the problem with ground crews is coverage per day. So there's a gap, and that gap is being filled with drones. So a fixed-wing drone has to be moving forward all the time. So its accuracy, while great, is more in the 2 inches per pixel area. This is really good. But then with the multi-rotor, because it can fly very slowly, we can get down to 3/4 of an inch per pixel. This is great. In terms of price, drones are pretty cheap compared to airplanes and satellites. So all it costs really is the price of having the crew out flying the drone. And that leads to how much, because the multi-rotor is going kind of slow, we figure it can get up to about 5 miles per day. The manned or fixed wing can get up to like 15 square miles a day. This is all going to change by next year when we get our ability to fly beyond line of sight. All right, so we solved the accuracy problem, we solved the price problem, and we solved the efficiency problem, assuming we're looking at 15 square miles per drone per day. So more crews equals more coverage. But wait, there's more. We've got to talk about our sensors and our data collection practices, which have brought in a whole new capability as far as making maps. Because we fly so low, and because we use a variety of different sensors, we can provide a number of different advanced outputs, such as three-dimensional maps and virtual environments. We use high-tech sensors like near-infrared, hyperspectral, LiDAR to provide detailed, statistically based maps for things like precision agriculture, showing crop health, volumetrics, showing, for instance, how much ore we have in this tailings pile, and vegetative analysis, showing fire fuel levels in sensitive range habitats. We do analysis on the data we collect and provide it to the customer with actionable information which improves their business. When we fly, we take hundreds and hundreds of high-resolution pictures. And if you look at them individually, they don't add up to much. But combining them all allows us to make a high-resolution, multidimensional map. These maps are three-dimensional, and we can look at a point cloud, which is hundreds of pictures all put together, to to see things about the elevations. Take, for example, these rocks. As we look at this rock formation, we can see from a top-down view and two-dimensional of what the rocks are. We can take a pretty good look at those plants as well. But as we look at it in a three-dimensional point cloud, we can actually look at the details on the sides of the rocks. This is from taking a lot of pictures from a lot of different angles. And we could actually carve this out and put it in a 3D printer and make a copy of the rocks if we wanted to. This is a digital elevation file. In the nearby area, we can zoom in and look at some data collected so we can actually look at the different plants. And we can zoom in and see what those plants look like and what species they are. Near infrared allows us to do a procedure called NDVI. Healthy leaves reflect more near infrared than unhealthy leaves, and each different plant has a different signature as to how much reflection it gives. So you combine what species it is with what its digital signature is, and you can find out more information about what's on the ground. To visualize this, we'll flip back and forth between NDVI and regular photography. Because we've merged so many high-resolution pictures together, we can actually look at very close up, or we can actually look at a three-dimensional model of the same area. Zooming in and around on this little test plot shows us that we can measure the actual height of each plant. This is important, and we're capable of it because we can fly so low. This is an area in northern Nevada, and you can see as we zoom in, there's cheatgrass, there's bitterbrush, sagebrush, etc. When we look at this with near infrared, we can see that there's different signatures being given off. And then with NDVI, we can actually flip back and forth, and the computer is capable of figuring out what the individual signatures are based on height, hyperspectral information, and near infrared information. We can then put this into a bunch of different charts and histograms to see the digital signature of each different species based on all those three parameters. The combination of all this allows us to put together a detailed report that says exactly what the habitat's all about. That does away with the need for laborious and estimate on transects done by live humans that can be wrong or just not cover enough ground. For sagebrush ecosystems, this is enormously important for habitat management and invasive plant species control. There are a great many more things that we can provide as products and deliverables, and as I mentioned earlier, there are a lot of things on the forefront, such as drone delivery and all those other fun things. As system integrators, AboveNV provides end-to-end solutions specific to customer needs, from flight planning to the final report. But drones are not the product here. It's important to point out it's the analysis, the report, the actionable information is the product. Our aircraft are many, and each is designed to satisfy specific mission requirements. We have a variety of post-processing capabilities that focus our efforts specifically on the end result. Our product is the result, not the tools we use or the process. At the end of the day, our most important products are expertise and information. So I'd love it if you could give me a call. I'd be happy to answer questions, and I hope we can help you out. Again, my name's Kirk. I'm from AboveNV, and thanks for your time listening to this presentation.